Alright, most characteristics. So let's look at the ID versus VDS. So you're pretty much familiar with this graph. So I just want to talk about the graph. So when you increase your voltage, drain source voltage, we're talking about drain source voltage, drain, source and gate. It's almost like a linear relationship first, and that is our triode region, or we also call it linear. And then your output current, your current here, saturates and it stays almost the same. Well, say almost the same because the saturation equation has the VDS here that makes your output change, increase a little bit, and that's basically with lambda effect, channel length modulation, and this is without lambda. So you can see the equation, you have the square for VGS, so if you increase VGS your current increases, but also it's linearly dependent. And the saturation, the region that starts here, that's when VDS is much greater than VGS minus VTH. So higher VDS, then you're in saturation and you want saturation. In triode region, you have a similar equation, well, not so similar. You have VGS here again, but there's no square root of square term, and you have VDS here already. So for triode, we don't talk about the lambda effect because there is no lambda effect here. And this happens when VDS is smaller than VGS minus VTH. So smaller VDS voltage, that you're mostly in triode. Okay, now I'm going to throw you a curveball. We'll talk about ID versus VGS. I'll tell you why it's a curveball. So it's perfect. VGS, look at this one again, saturation. So this equation starts when you have the voltage in VGS higher than VTH. So if VGS is higher than VTH, then your transistor is on. But we don't know if it's in saturation or triode. So until here, it's 0. Perfect. But then it increases with the square. So I want to focus on here, right here, if our transistor is in saturation or triode. Well, we look at VDS and VGS minus VTH. So your VGS is just a little bit over VTH. So this is almost close to 0, or maybe 0.1, and it continues to increase because we're looking at basically this distance. And your VDS, which we don't know at this point, but we assume that you have a VDS value there, and usually VDS value is much higher than that. So here your transistor is actually in saturation, not in triode. It goes to triode region when this term increases and increases more, that it becomes more than VDS. So you increase your VGS, increase, and at some point your transistor is going to be in triode region, and because in the triode region your equation is different, this curve here is not going to go like exactly exponential. It'll still increase because you have VGS here, but it's going to be more linear, so it's going to be going a little bit different slope. Instead of going like this, it's going to go a little bit different slope.